In this problem, we're identifying which type of function we're dealing with based on the table and the data, or the data, excuse me, the data in the table, and we have linear, quadratic, or exponential. So first of all, we have to ensure that the inputs are increasing by a constant amount in order to be able to even begin to judge. We notice that here the increases in the output, or the change in y's, are all 20, and so therefore this would be, so there's change in y, they're all constant, so this would have to be a linear function. Here, if you notice that it changes by 0.5 and then it changes by 0.75, so it can't be linear, but if you compare their ratios, you will always get 1.5. And same thing here, and same thing down the line. Whenever you compare the current y to the previous y, and again, same important idea that all these inputs are increasing by a constant amount, or else you can't compare adjacent outputs if the inputs aren't adjacent. So in this case, well, you'd probably test to see if it's linear, which it's not. The increases aren't all the same. You'd look at the ratios; they're not constant, but you look at the change in y's, which goes 4.6, and then 5.8. And then let's see, so that's going to be 7, and this will be 8.2, and this will be 9.4. So we look at the differences in the change in y's, that is the change in the slopes, and the slopes appear to be increasing by 1.2 constantly. And since the change in the rate of change is constant, we would say that this is a quadratic function.